questions 11 through 20 on the 2015 grade 9 Pascal math contest. Jim wrote the sequence of symbols a total of 50 times. How many more hearts than spades symbols did he write? If you look at that original sequence, there's 9 symbols, right? And of those 9 symbols, 5 are hearts, and 2 are those spades, however you draw them, and 2 are diamonds. So if we are going to write them out 50 times, then basically you would be multiplying those by 50. So you would get 250 hearts, and you would get 100 of those spades, and you'd get 100 diamonds. So they're saying, how many more of these hearts are you going to have than these spades? Well, there's 250 hearts and 100 spades. So 250 minus 100 is 150. And that is the answer they are looking for. Number 11, therefore, is B. What is the smallest positive integer that is a multiple of each 3, 5, 7, 9? So basically what they're asking for is the LCM, lowest common multiple. Or least common multiple, whatever you want to call it. So the way to do this, of course, is you look at the numbers and you break them up into prime factors. Well, 3, 5, and 7 are already prime, but 9 is 3 times 3. And then what you do is for each of these numbers, you included the maximum number of time it appears. So 3, for example, the maximum it appears is twice. So you have to use it twice at least. So LCM is calculated as follows, right? 5 only appears once, 7 only appears once. So this is the LCM. 9 times 5 times 7, which is 315. So number 12, the answer is D. 16 squares are arranged to form a region as shown. Each square has an area of 400. Anna walks along the path with the solid line formed by the outer edges of the region exactly once. Aaron walks along the dotted path formed by the inner edges of the region exactly once. In total, how far did Anna and Aaron walk? Well, each square has an area of 400, right? So what that basically means is that since a square has same sides, x squared is 400. So x is 20. So each of those sides is going to be 20 in length. Now we just have to count up all the sides that Anna crosses and Aaron crosses. So for Anna, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20. And each of those has a length of 20. So her path is a total of 400 meters. And then very similarly for Aaron, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 of those lines, and each of those lines is 20. So he is 240. And then now we just have to add up 400 and 240 to get their total path distance, and that is 640. So number 13, the answer is E. The operation symbol is defined by A symbol B is A over B plus B over A. What is 4 symbol 8? So that would be, according to the definition, 4 over 8 plus 8 over 4. So that's going to be 1/2 plus 2, and 1/2 plus 2 is 5 over 2. So number 14, the answer is E. At the end of the year 2000, Steve had $100 and Wayne had $10,000. at the end of each following year, Steve had twice as much money as he did at the end of the previous year, and Wayne had half as much money as he did at the end of the previous year. At the end of which year did Steve have more money than Wayne for the first time? So end of year 2000. We have Steve here and we have Wayne here, so it's 110,000. So end of 2001, end of 2002, and so on, right? So the answer choices go up until 2006, so let's just write until 2006. Let's see what happens. Okay, so at the end of 2001, Steve doubles and Wayne halves, so we got 205,000. Next year, same story, 400, 2,500. Next year, 800, 1,250. Next year, 1,600, 625. And at this point, for the first time, Steve has more money than Wayne, and that happened in the year 2004. So number 15, the answer is C. Anka and Bruce left Mathville at the same time. They drove along a straight highway towards Staten. Bruce drove at 50 kilometers an hour. Anka drove at 60 kilometers an hour, but stopped along the way to rest. They both arrived at Staten at the same time. For how long did Anka stop to rest? Speed is equal to distance over time. Time is equal to distance over speed. First, let's talk about Bruce. Bruce, his distance, of course, 200. His speed is 50. So his time is 4. Right? 4 hours. Anka, same formula, of course, 200 and divided by 60. That's her speed. And that is 3.3 1/3 hours. But they're saying that they both arrived at Staten at the same time. Well, how's that possible? Well, it's because Anka stopped along the way to rest. So the amount of time she rested must be the difference between 4 and 3 1/3. So, what is the difference between 4 and 3 1/3? Well, it's 2/3. 2/3 of an hour, which is 40 minutes. So Anka drove 3 hours and 20 minutes. She stopped somewhere along the line for 40 minutes, and that's why her total time ends up being 4 hours, and that's why she arrives at the same time as Bruce. So the answer to number 16 is 40 minutes, which is A. In the diagram, 6 identical circles just touch the edges of rectangle PQRS, and each circle just touches the adjacent circles. The centers T, V, W, Y of 4 of these circles form a smaller rectangular T, V, Y, W, Y as shown. The centers U and X lie on this rectangle. If the perimeter of T, V, W, Y is 60, what is the area of PQRS? All right, well, what I'll do is I'll call the radii R, like that. Each of these is R. So the first thing, of course, is that the perimeter of TVWY is 60. TVWY, if you count up all the R's, I'll just keep labeling them like that. How many R's do we have? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12R is the perimeter of TVWY, that rectangle. Well, they told me the perimeter is 60. So 12R is 60, and therefore R is equal to 5. Now they want you to find the area of PQRS. Well, PQRS, those dimensions are going to be 1, 2, 3, 4, 6R on this side, and 1, 2, 3, 4R on that side. So the area of PQRS will be 6R times 4R. That's 24r squared. R is 5, so 24 times 5 squared, 24 times 25, and that is 600. So, number 17, the answer is A. In a magic square, the numbers in each row, the numbers in each column, and the numbers on each diagonal had the same sum. In the magic square shown, the sum A plus B plus C equals. All right, so this one here and this one I will equate. So A plus 19 plus 12 is the same as 19 plus C plus 11 because all the rows and the columns have the same sum. So this means that A plus 1 is equal to C. That's pretty much all we can get there. Or if you want to write it, A is equal to C minus 1. Same thing. Okay, so now let's get a similar relationship between B and C. So I'll use this column, and you might as well just use that row again. So B plus 11 plus 16 is equal to 19 plus C plus 11. So that means that B is equal to 3 plus C. All right. So now let's look at my A plus B plus C. What could it be? A is C minus 1, B is 3 plus C, and I've got this C. So this becomes 3C plus 2. So A plus B plus C is of the form 3C plus 2, where C obviously is a number because it says numbers. So which one of these answer choices is of the form 3C plus 2, where C is an integer? Well, the only ones that are of that form are 47 and 50, because the other ones, if you were to try to put it in that form, C would not become an integer. So this is out, and this is out. But we still have two. We have to figure out which one of those. Okay. Well, first let's figure out what is C for each of those. If it's 47, that means C is 15. If it is 50, then that means C is 16. All right, so let's make a table now. A, B, and C. And let's do it first for 47 and then for 50. Well, C we just figured out was 15 here and 16 here. Since A is C minus 1, this is going to be 14 and this will be 15. And since B is 3 plus C, this will be 18 and this will be 19. Okay, so now we have to go back and figure out which one of these will actually work. Which one of these triplets will actually fit the square properly. So let's see here. Let's draw a little square and try to recreate this. And let's see if these numbers fit. If they actually match the criteria of the question. And I think we could do this pretty quickly. Just concentrating on just a few rows actually. Just two of them. 2 rows or 2 columns. I'll just concentrate on the first 2 rows. I don't think we need to worry about the D. So we have A, 13, and B for the top row, so that for this guy, this triplet, it would be 14, 13, and 18. And then the second row would be 19, 15, and 11. Okay, so let's add these up. Let's see what we get. 14 plus 13 plus 18 is 45. Okay, so far so good. 19 plus 15 plus 11 is 45. All right, so that works. So far, it seems like it's pretty good. And I think for the sake of time, I'll just leave it at those two. So I'll say, okay, this is good so far. So now let's do the same thing, but this time using these other numbers that we got for that second triplet. So now I'm going to use these numbers here, the 15, 19, and 16. So 15, 13, 19, 19, 16, and 11. Okay, so now let's do this here. 15 plus 13 plus 19, that's 47. 19 plus 16 plus 11 is 46. Well, as you can clearly see, that does not work. Those numbers are not the same. So this, not good. So that means it's not 50, it's 47. So 18, the answer is C. Christina has some raisins. She gives 1/3 of her raisins to Mike. She then eats 4 raisins, after which she gives 1/2 of her remaining raisins to Anna. If Christina then has 16 raisins left, how many raisins did she have to begin? Well, let's just say she starts with X. And then we've got Mike, and we have Anna. She then gives 1/3 of her raisins to Mike. So if she gives 1/3 away, that means she has 2/3 remaining. Then she eats 4 of her raisins. So now she has 2x over 3 minus 4. And then Mike still has x over 3. And then she gives half of what she has remaining to Anna. So half of what she has remaining would be half of 2x over 3 minus 4. And then the other half, of course, she still has. And they are saying in the question that this is 16. So that is the algebra. 1/2 times 2x over 3 minus 4 is equal to 16. Multiply both sides by 2, and we have 2x over 3 minus 4 is equal to 32. 2x over 3 is 36. 2x is equal to 108, and therefore x is equal to 54. So number 19, the answer is B. Andre has an unlimited supply of $1, $2, and $5. Using only these coins and bills and not necessarily using some of each kind, in how many different ways can he form exactly $10? All right, let's make a little table. So I've got $1 coins, $2 coins, and a $5 bill. And I've got to make some combinations that end up equaling $10. Okay, well, let's see here. I can have 10 of these and 0 and 0. I can have 8, 1, and 0. I can have 6, 2, 0, 4, 3, 0, and 2, 4, 0. That would all equal $10. Now let's see what we get. I think 0, 5 would also do it. Okay, I think I've exhausted pretty much the zeros for $5. And now I have to include a $5 bill. So 1, 0, and 5 would do it. 1, 1, and 3. 1, 2, and 1. And I've exhausted the $1 combination. So there's only one other way, and that is having 2 of those $5 bills. And I think that's it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Therefore, number 20, the answer is A.